Hey everyone, my name is Vankar and welcome to Traffic. So in today's session, we'll be discussing some beautiful questions on analog electronics, especially on the diode circuits. So before moving into the questions, I'll give you some basic to solve the questions. So this is the very basic question from diode electronics, from diode circuits. So how to solve such type of questions? So to check in this question, we have to figure out whether these diodes are on or off. So how to judge whether a diode is off or on? So to decide whether the diodes are off or on, we perform few basic tests. One is OC test, which we call the open circuit test, and another one is SC test, which is the short circuit test. Short circuit test. So when we perform the open circuit test, we always take the voltage across the diode to judge the on or off condition. If the VD is greater than 0 for ideal diode, then we can say the diode is on. Similarly, if VD is less than 0, then the diode is off. Similarly, if the VD is greater than zero point 0.7 volt in case of a practical diode and the diode is, let's say, silicon diode, then we can say the diode is on. And if the VD is less than zero point 0.7, we can say the diode is on. Similarly, we know that for the germanium, the cut-in voltage is 0.7, 0.3 volt. Then diode is on. If it is less than 0.3, then the diode is off. Similarly, for the short circuit test, we take ID, the current across the diode, to decide. This is the deciding parameter to judge the turn on or turn off of the diode. Okay? If the ID is greater than 0, then the diode is on. Similarly, if the ID is less than 0, then the diode is off. So let's apply these basics. Let's apply this concept to solve this question. So as you can see, there is 10 volt applied at one node and minus 10 volt is applied at another node. You can consider any test to solve this question. And initially, we have to take an assumption. Let's say we have to assume initially, let's say D1, D2, and D3 are off. We have to assume something. Whether you can consider it as on. I am considering it is off to for the sake of easiness to calculate. So let's calculate the diode first. Let's calculate the current through this branch. As the diodes are off, let's put a cross mark across the terminals. So if I see the current Ix, you can say 10 minus of minus 10 by 10k. It comes out to be 2 milliampere. Okay. And let's give name these diodes the terminals. Let's say this is VA, this is VB, this is DC. So if I calculate VA, it will be 10 minus 1k times 2 milliampere. This is 8 volts. Similarly, VB is 8 minus 2k times 2 milliampere. So it will be 4 volts. Similarly, VC, it will be 4 volt minus 3k times 2 milliampere. is minus 2 volt. So you can see that for diode 1, the VD1, this is the VD1. As I told you, if you are considering the open circuit test, you have to consider the voltage across the diode to judge the turn on and turn on conditions, turn off conditions. This is VT2 and this is VD3. So VD1 is equal to, you can say VA minus or minus 2 volt, right? VA is 8 volt plus 2 volt is 10 volt. This is 0, greater than 0. As these are ideal voltages, these are ideal diodes. So the cut-in voltage is 0, as we saw in the previous slide. Okay. Similarly, for VD2, if I say VD2, then VD2 is VB minus or minus 3. Okay, VB we calculated 4 volt plus 3 volt is 7 volt. This is again greater than 0. So VD2 is also on. Similarly, let's calculate VD3. Then what is VD3? VD3 VC plus 5. I'm writing this directly. VC is minus 2 volt plus 5 volt. This is 3 volt greater than 0. So you can see initially we have assumed that all the three diodes to be off. Now we calculated using the open circuit test and to show that all the three diodes are on. So now your task is to solve the same question with short circuit test. As I gave you the basics that for short circuit test, you have to calculate simply ID1, ID2, and ID3. If you are getting these three currents to be greater than 0, you can say that then these three diodes are on, and you will get the exact same results. Okay, so this is the answer: D1, D2, and D3 on. Right. So let's move next to the next question. So actually, I have just taken the screenshot from various resources to just give you a practice session. So the numbering are a bit absurd. So ignore that. Let's solve the question that is the primary focus. Okay. So you can assume in such type of question there is no specific limits that you have to assume both are on or both are off. It's not like that. You can assume anything on. You can say this is on, this is off, or this is on, this is off. You can assume anything depending on your feasibility. In whichever calculation you are comfortable with, you can assume accordingly. So I am assuming D1 to be on and D2 to be off. So before solving the question, I'll give you one formula. I will give you, or you can say basic, which I'm going to use in the entire series. This is called the voltage divider formula, or 1 plus R. And this will be used in every diode, MOSFET, BJT, op-amp, across the complete electrical, EC, and IM. Whichever branch you are considered or you are from, this formula is useful. Okay. So assuming D1 to be on, D2 to be off, let's put a cross mark here and let's name this node to be Vx, this node to be Vy. Let's calculate Vx, if I calculate here Vx. Vx is I can using this formula I can calculate 10 by 15 times 15 volt. Where the node voltage is after 15, 15 volt. This is 10. Similarly, Vy is, this is the reference 5 divided by 15 times 15. This is 5. So you can see very simply that is for D2. the Vy minus Vx, or you can see the similarly Vd2. This is exactly Vd2. You can say Vd2 is what? 5 minus 10 minus 5, which is less than 0. So D2 is off, and I also assume D2 to be off. Okay, so this assumption of mine is correct. Let's check same for the Vx. For D1, I have assumed the short circuit test, I have assumed it to be on. So I'll consider the current across it, right? Here I consider the voltage, here across I am considering the current. What is the current idea? Basic KCL, basic node analysis, basic KVL, everything is from basics. Dx is 10 divided by 5, 1 million. And this comes up to be better than 0. This is positive. Okay, positive means current is flowing from Q to N, right? And this is the basic principle of diode. Current should flow from P to N. So D1 is on and D2 is off. We have assumed this is we have assumed earlier, and this is the answer. This is the second question. This is the third question. Uh, and you can use short circuit, or you can use open circuit, whichever you are comfortable with using. Let me assume that these two are on and this one is off. Okay, so let me put a cross mark here. This is let let's say this voltage is VD3, as we are calculating across the VD3. Yes, this is VD3, and as it is open, there is no drop across the 10. So this is VD3. What is VD3? 10 divided by this here is 20k, so 30k into 10. This supply is 10. So 10 by 3 volt, right? So this is VD3. Let's assume this is the reference 0 volt. So VD3 is greater than 0. Okay, all the three diodes are ideal. Let's assume all the three diodes are ideal. So VD3 is greater than 0. So B3 is on. But we have assumed these are on. Okay, so we have to check the current through it. So what is I? 10 minus 10 by 3 divided by 20k. This comes out to be 1 by 3 milliamperes. These are also greater than 0. So D1, D2, D3, all are, all are, right? Now this is the next question. And you can take an assumption here, as you can see this is minus 10 volt, here it is ground, here it is plus 10. And this is although there is a resistor connected here, but this will affect the anode, and this is affecting the cathode. This is affecting the cathode. So now this is also affecting to the cathode. It is in the direct connection to the cathode. Okay. So we can take an assumption that D1 is on, and also D1, D2 is on. There is a more possibility that both the diodes can be on. Okay, let's check. Assume that these both are on, so I have to go through the current. This is ID2. Okay, so if this is on, this will be 0 volt. This reference voltage will directly come here. Okay, 0 volt. So what is ID2? 10 minus 0 by 5 is 2 million, right? This is greater than 0, so you can simply decide that D2 is on. You can simply comment that D2 is on. What is this current Ix? 0 minus of minus 10 divided by 10, 1 milliampere, right? What is ID1? That is ID2 minus Ix by KCL. 2 milliampere minus 1 milliampere. 1 milliampere. This is again greater than 0. So D1 need to on. Yes. How to get this question? Now this is an homework. You can take it as an homework, right? So I suggest practice this question by your own. Okay, apply short circuit or open circuit and write the answer in the comments below. Okay, at the comment section, write down the answer. Key whether you found D1 on or D2 off or D2 on D1 off. Okay, or both on or both off. Just write down in the comments. Uh, let's solve this one. This is a one diode question. This is an easy one. You can say, let's say, let me assume D is your task is to solve with D is on. Okay. So if I say D is off, okay, I have to calculate okay, yeah, but it is given that this is already in forward bias. Okay. So I have no option. I have to do this. This is 5 volt, right? If this is 5 volt, and I already gave you the basics, if this is on, I have to just go through the current. So what is this? Let's say this is IX. Let's say this is IY. What is IY? VI minus 5 by 300. Equation number 1. Similarly, IX 5 minus 2 by 5. 3 by 5. Right? Or I can write this as 6 milli. So what is ID? IY minus IX. VI minus 5. I can write that it's minus 0.3 K equal to minus 6 milliampere is greater than 0. As we know that if ID is greater than 0, then T is in forward bias. Right? So Vi minus 5 by 0.3 K is greater than 6 million. Or Vi minus 5 greater than 1.8 volt. Or I can say Vi is n greater than 6.8. So what is the Vi minimum? To solve this is 6.8 volt. We need this much amount of minimum voltage level to make this diode on. Okay. So this much is for today. In the next session, we'll solve more advanced problems and we'll see what we can expect from diode circuits. And as per your response, we'll decide to bring more and more initiatives. Let's say power electronics or control system, their question session and their bite-sized concept videos for you for your better revision and practice. So thank you so much. And if you like this video, then do like this, share, and consider to subscribe this channel. Thank you so much. See you in the next one.